All right. Second section covers question number 4 only. It says you can use the angle similarity postulate to show that two triangles are similar. In order to prove why this criterion works, you must show that if it follows from the definition of similarity in terms of rigid motion. Here we have 4. To justify the angle-angle similarity postulate, consider the two triangles below. What given information is marked in the figure? Based on the definition of similarity, explain whether transformation can show that that ABC is similar to DEF. C. Draw a figure to show the result of a dilation that maps triangle ABC to triangle A'B'C', using the scale factor of K, which is equal to DE over AB. Letter D. By the definition of similarity transformations, complete the following statement. Angle A prime is congruent to blank. Angle B prime is congruent to blank. And angle C prime is congruent to, got carried away. Angle A prime, B prime is equal to K times AB, which is equal to blank. By the transitive property of congruence, angle A prime is congruent to angle D and blank. F. How are triangle A prime, B prime, C prime, and triangle DEF related, and how do you know? So here we are going to be working through one question, but it contains 6 parts. So I'm going to go with a 5-minute time limit to answer all of question number 4. Go ahead and pause your video now. All right, so I have finished question number 4. I've stated that angle A is congruent to angle D and angle B is congruent to E because that was what was marked on those pictures. It says a sequence of similarity transformation, which does include dilation, will map triangle ABC to triangle DEF. It says draw a figure to show the result of a dilation that maps triangle ABC to triangle A'B'C' using the scale factor of K equal to DE over AB. Well, first thing I did was I started with what we were given, the small triangle. I then said, okay, I'm going to multiply each piece by a scale factor of DE over AB. So I have my length has grown on all 3 sides, but A is still congruent to A, B is still congruent to B. Well, really, those are the primes, are congruent to the original. And then I know that A prime is congruent to DE, the side lengths, and since I know those are equal, I can go on to state here in just a little bit that A prime, B prime, C prime is congruent to DEF. Let's go keep moving forward. Here we have angle A was congruent to angle A prime. Angle B prime was congruent to angle B. And this should say, not angle, this should say just line. This should be a line. This should say A prime, B prime, the line, is congruent or equal to K times AB, which is congruent to DE. We also know that by the transitive property, if angle A prime was equal to angle D, we also know that A and D were equal to each other, so A prime is equal to D. And since B and B prime were equal to each other, and B was equal to E, we know that B prime is equal to E. And we can state that the two triangles, A prime, B prime, C prime, and DEF are related by a congruency statement because of angle, side, angle. And you'll see that whenever I marked it here, I said this angle is congruent to this angle, this side is congruent to this side, and this angle is congruent to this angle. So angle, side, angle. On to the next set of questions.